Hello everyone, I am Himanshi from DNA Education and today we will take further the topic of carbon and its compounds to learn some new topics. So let us begin. Today we will learn about the chemical properties of carbon compounds. Let us study them one by one. First is combustion. Combustion is a general term which we use for a reaction of any object or any substance with oxygen. For example, carbon reacts with oxygen to form carbon dioxide and heat and light are evolved. In all the combustion reactions of carbon compounds, carbon dioxide is evolved along with heat and light. As in the another example we see, methane reacts with oxygen to give carbon dioxide, water, heat and light. So this is a general equation representing combustion's reaction of carbon compounds. Moving on to the next topic is oxidation. As we have already discussed that oxidation is addition of oxygen in a substance. So you can see that here it is ethanol because it contains OH group. So ethanol is converted into ethanoic acid. As you can see, there is only one oxygen, however it has two oxygen atoms, hence it is an oxidation reaction and this takes place in the presence of alkaline KMNO4 or acidified K2Cr2O7 in the presence of heat. So this is oxidation of carbon compounds. Another important reaction is addition reaction. This reaction is very important, so let us study about this. The unsaturated carbon compounds can be converted to saturated carbon compounds by the addition reaction. We can add alkyl groups to an unsaturated carbon compound to make it saturated. Here we can see that CC double bond and there are 4 alkyl groups. In the presence of catalyst nickel or hydrogen, it can be converted into a saturated compound by addition of 2 more alkyl groups. This addition reaction is very important during the formation of vegetable oils and vegetable ghee. As we know that some compounds are unsaturated and some are unsaturated. Similarly, oils, edible oils can be saturated as well as unsaturated. The saturated oils and ghee are unhealthy for us because these are very stable compounds and difficult to digest. However, unsaturated oils and ghee are easy to digest because these are made up of double or triple bond and hence they are quite unstable as compared to the saturated compounds and hence can be digested easily. Hence, during cooking or while eating, we should select unsaturated oils and fats for consumption. Moving on to the next is the substitution reactions. Carbon compounds can undergo substitution reaction in which we can replace one or more hydrogen atoms from the compound with any other element that is required. Here in this example, methane reacts with chlorine in the presence of sunlight and we can see that one hydrogen atom is replaced by one chlorine atom. So it becomes CH3 and Cl. One hydrogen and one chlorine here combines to form HCl. In this way, we can further this reaction. For example, we can again add one more Cl and replace one more hydrogen from CH3Cl and this reaction can go on. This is the basic substitution reaction. Now, after all this, we can understand that carbon has 2 important compounds that we have to study in class 10th. That is ethanoic acid and ethanol. Ethanol is represented by CH3CH2OH as we have already discussed. Because it has 2 carbon compounds, hence the name ethan, and OH is represented by ol. Similarly, ethanoic acid is CH3COOH, again 2 carbon atoms, hence ethane, and COOH represented by ethanoic acid. Now, these two are very important. Ethanol is the purest form of alcohol and can be converted into several other usable compounds. Ethanoic acid, it is a form of vinegar. For example, we say that 5 to 8% solution of acetic acid or ethanoic acid in water is called vinegar that we use in our homes or at other industries. Now let us go to the esterification reaction. Esterification reaction is actually the reaction of ethanol and ethanoic acid to form ester. Let us see how the reaction occurs. This is acetic acid or ethanoic acid, CH3COOH. It reacts with ethanol, CH3CH2OH, to form ester, which is this compound plus water molecule is released. Basically, this hydrogen and this OH group, they combine to form water molecule, and this rest of the compound joins to form the ester. This ester is a fruity smelling compound. It has a very fruity and sweet smell. Now, exactly opposite to this reaction is the saponification reaction. Saponification reaction, as the name suggests, is the reaction for the manufacture of soaps. The general formula of soaps can be RCOONA. R can be an alkyl group or a long hydrocarbon chain, and this is a carboxylic acid in which hydrogen is replaced by sodium ion. So we say that soaps are sodium salts of carboxylic acids. So in saponification reaction, we will see how sodium salts of carboxylic acids or soaps are formed. Here, ester reacts in the presence of a base to give back ethanol and acetic acid, sodium acetate, because in pure ethanoic acid or acetic acid, there is one hydrogen, but here the hydrogen is replaced by sodium atom, so it is called sodium acetate. So basically, ester reacts to form alcohol and carboxylic acid, whereas in esterification reaction, carboxylic acid and alcohol reacts to form ester. Hence, it is very clear that these two reactions are completely opposite to each other. So we have seen how due to saponification reaction, we can get soaps. Now let us see what a soap molecule looks like, what is its structure and how does it work. This is a basic soap molecule. A soap molecule consists of two parts. One is the hydrophilic end and other is the hydrophobic chain. Hydrophilic is made up of two words, hydro and philic. Hydro means water and philic means attraction. So this part of the soap molecule is attracted towards water. Hydrophobic is made up of two words, hydro and phobic. Hydro means water and phobic means repulsion. So basically this part or this molecule, this part of soap molecule is repelled by water molecules. So this is the basic structure of a water molecule, and this ionic head is represented by sodium ion, because in a molecule of soap we see that sodium atom is there and it is a charged species. So this charge is attracted by water and hydrophobic tail is repelled by water. Now whenever we make cleaning action of soap, so soap molecules arrange themselves as a sphere, as a ball in this manner. In this arrangement of the soap molecules, the hydrophilic ends project outwards while all the hydrophobic tails are inside the sphere, and the dirt molecule is trapped in between these chains. And when we rinse the cloth and wash it with water, the dirt particle along with the soap molecule structure, complete structure, it is washed away and cleaning occurs. This structure of soap molecules is called micelle. So this is all for today's session, and for more details you can log into www.dnaeducation.com. Thank you.